Hello and welcome back to my channel. In this video, we will be talking about the evidences and causes of climate change. Climate change is any significant change in the Earth's climate over a long period, especially due to an increase in average atmospheric temperatures. According to scientists, the Earth was formed 4,600 million or 4.6 billion years ago. To make geologic time easier to understand, these scientists divide the Earth's history into broad units of time called eons. The eons are divided into eras, eras into periods, periods into epochs, and epochs into ages. The most recent 2.6 million years of the Earth's history is known as the Quaternary period and is part of the Cenozoic era. The Earth's climate was warmer and more stable before the Quaternary period. Since then, things have changed quite significantly. During the Quaternary period, global temperatures have shifted between cold glacial periods and warmer interglacial periods. Glacial periods have lasted around 10 times longer than interglacial periods. The Quaternary period is divided into two epochs, the Pleistocene and the Holocene epochs. The Pleistocene epoch, which preceded the Holocene epoch, had a substantially longer sequence of alternating glacial and interglacial ages. The Holocene, which followed, has been identified with the current warm period and represents the most recent interglacial interval of the Quaternary period. Since the last glacial period 15,000 years ago, the climate has been warming. Global warming is the term used to describe the rapid increase in global temperatures over the last century. Scientists are able to find out what temperatures were in the past by using indirect data stored as fossil record found in deep ocean sediments and frozen ice cores. In more recent times, scientists measure temperatures by the use of thermometers. From these data sources, scientists have been able to discover that there has been a clear warming trend in the latter part of the Quaternary period. However, there are other evidences of climate change, such as glacial retreat, seasonal changes, rising sea levels, and dendrochronology. Glaciers that exist today are remnants of the last ice age. Notice from the map that continent-scale ice sheets still cover Greenland and Antarctica, while small ice caps and glaciers have retreated to the world's high latitudes and high altitudes or mountains. The retreat and disappearance of mountain glaciers around the world is among the most dramatic evidences that the Earth's climate is warming. The graph shows ice loss relative to 1970 for the glaciers. Glacier mass balance refers to the annual balance between how much snow accumulates on a glacier and how much ice is lost through melting, sublimation, or iceberg calving. These glaciers have lost a volume of ice equivalent to about 27.5 meters or 90 feet of water spread out over each glacier. Arctic sea ice has thinned by 65% since 1975. The total area of Arctic sea ice was at an all time low in 2014. Based on the trends, some glaciers may disappear completely by 2035. As the world's climate changes, plants and animals are being exposed to new environmental conditions, including changes to the timing of seasons. Migratory birds split their year between different locations that are thousands of kilometers apart in order to gain maximum benefit from each location in terms of food and weather conditions. In recent years, studies have suggested that birds are arriving at northern hemisphere breeding grounds earlier as a result of global climatic changes. This could be problematic for these birds. According to the Intergovernmental Panel on Climate Change, the average global sea level has risen between 10 and 20 centimeters in the past 100 years. This is due to the melting of ice, which flows as water into the sea, increasing its volume. Additionally, when the ocean water heats up, it expands in volume. This is known as thermal expansion. Tree rings usually grow wider in warm, wet years, and they are thinner in years when it is cold and dry. If the tree has experienced stressful conditions such as drought, the tree might hardly grow at all in those years. This means that the characteristics of the rings inside a tree can tell scientists what the weather conditions were like during each year of the tree's life. Very old trees can offer clues about what the climate in an area was like long before measurements were recorded. Climate change is the result of both natural as well as human causes. Natural causes of climate change include volcanic activity, solar activity, and orbital changes. Large quantities of materials, including ash, steam, and various gases, can be blasted in the atmosphere when there is an explosive volcanic eruption. The volcanic ash can block out the sunlight, resulting in the decrease of temperatures at the surface, but this tends to be a short term impact. During the volcanic eruption, sulfur dioxide can be converted to sulfuric acid, which reflects sunlight. This can have a more long term impact. The cooling of the lower atmosphere and reduction of surface temperatures is known as volcanic winters. A sunspot is a dark patch that appears from time to time on the surface of the sun. The number of sunspots can increase or decrease over a period of 11 years. This 11-year period is called the sunspot cycle. When the sunspot activity is at a maximum, the sun gives off more heat, in which increases temperatures at the Earth's surface. When sunspot activity is at its minimum, solar output is decreased, which leads to lower temperatures on the Earth's surface. Milutin Milankovitch studied the Earth's orbit and identified three distinct cycles that he believed affected the world's climate. These are known collectively as the Milankovitch cycles. Scientists believe that these cycles affect the timings and seasons of the Earth's climate. Eccentricity describes the path of the Earth as it orbits the Sun. The orbit is not fixed, but changes from being circular to being elliptical. A complete cycle from being circular to elliptical and back to circular occurs about every 100,000 years. With a nearly circular orbit, the length of the seasons is about equal, but as the orbit becomes more elliptical, the length of the seasons will start to vary. Over long periods of time, this can trigger climate changes. Obliquity. The Earth spins on an axis that is tilted. Currently, this tilt, also called obliquity, deviates by 23.4 degrees from what would be a 90-degree angle toward the orbital plane. But this obliquity oscillates over time. Over the last million years, it has been swinging from 22.1 degrees to 24.5 degrees, according to NASA. During more tilted periods, the seasons on Earth get more extreme as each hemisphere receives more sunlight in the summer when it's tilted toward the sun, and less in winter when it's tilted away. Over time, the longer winters lead to the expansion of polar ice caps and continental ice sheets. At the peak of the ice ages, most of the Earth's land could be covered in ice, the planet turning into an inhospitable snowball. These swings of the tilt of the Earth's axis happen about every 40,000 years. Precession. As the Earth spins, its axis naturally wobbles in a circle like a spinning top. This effect is called axial precession and accounts for certain regions of the world experiencing very long nights and long days at certain times of the year. A complete wobble cycle takes about 26,000 years. Now, let us look at some of the human causes of climate change. A greenhouse is a small building made entirely of glass and used to grow plants under warm conditions. Like the greenhouse, the Earth's atmosphere allows heat from the sun in the form of shortwave radiation to pass straight through it and warm up the surface. However, When the Earth gives off heat in the form of long wave radiation, special gases called greenhouse gases, such as carbon dioxide and methane, are able to absorb the long wave radiation, trapping the heat like the glass of the greenhouse. In recent years, the amount of greenhouse gases in the atmosphere has increased largely due to human activities. With more greenhouse gases, more heat is trapped, resulting in global warming. Now, let's look at some of these greenhouse gases. Carbon dioxide accounts for an estimated 60% of the enhanced greenhouse effect, with global concentration of carbon dioxide increasing by 30% since 1850. Some of the sources of carbon dioxide include the burning of fossil fuels in factories and power stations, as well as in homes, car exhaust, and the burning of wood. Deforestation also reduces the rate at which the carbon dioxide can be removed from the atmosphere. Methane is very effective in absorbing heat. In fact, it accounts for 20% of the enhanced greenhouse effect. Some of the most common sources of methane includes the burning of biomass, rice cultivation, cattle rearing, and the decay of organic matter in landfill. Nitrous oxide. Very small concentrations of nitrous oxide in the atmosphere are up to 300 times more effective in capturing heat than carbon dioxide. Some of the common sources of this gas include car exhaust, power station, sewage treatment, and agricultural fertilizers. Other greenhouse gases that contribute to global warming include water vapor, ozone, and fluorinated gases such as chlorofluorocarbons. Okay, we are at the end of this video. Look out for part two on this topic where we will look at ways that we can respond to climate change as well as some of the impacts of climate change. Here I am going to leave you with some questions that you can try to answer And if you find that you are unable to answer these questions, just go ahead and rewatch the video until you are able to answer these questions. Once again, thank you for watching, and don't forget to like, to share, and to subscribe.